Use cases. Hey friends, today we will learn about use cases. Use cases or use case modeling is a very prominent technique used by IT business analysts on the project. Let's get started. Outline. Before we get to the detail of this lecture on use cases, let's briefly cover what the agenda is. We will start with introduction to use cases. We will then move on to decoding the use case diagram, followed by diving deep into use case diagram notations. We will learn about use case diagram relationships. We will cover certain additional topics which you cannot ignore. Finally, we will get to learn on how to produce a use case. We will close this session with the session summary. Introduction to use cases. First things first, we know unified modeling language consists of two kinds of diagrams, UML structure diagrams and UML behavior diagrams. Use case diagrams or use cases are UML behavior diagrams. What is a use case? Friends, a use case captures how the system or the software will be used or utilized by its end users. So say for example, in case of an attendance system, a use case will be mark attendance. In case of a flight booking system, there will be a use case called search flights. So these are the two methods, mark attendance and search flights, which are use cases for the respective systems on attendance and flight booking. In other words, you can imagine that a use case is a case of use of the system. So mark attendance is one case of use for the attendance system. Search flights is one of the many cases of use for a flight booking system. Let's learn it through an example on an online banking software. So for an online banking or a net banking software, use cases can be transfer funds, pay bills, request checkbook, view balance, block card, enable card, etc. So you see, for a given software or for a given system, there can be more than one types of user roles. So say for example, let's say block card and enable card as a functionality is available only to the administrators, whereas other use cases like transfer funds, pay bills, request checkbooks, view balance is available to all the account holders of this online banking system. So different users or different roles in a given software can have some different and some similar use cases. So what is a use case? At the cost of repetition, I'll tell you use cases capture what a system or subsystem will do. For example, for an online ticket booking portal, there will be use cases like issue ticket, cancel ticket, issue return ticket, etc. As a business analyst on the project or on the job, while you start your requirements elicitation activity or while you start the analysis of your project, you can start preparing use cases. Use cases can be fairly detailed in nature. Use cases, preparation and utilization. So who prepares the use case? Friends, by now we are aware that it is the IT business analyst who prepares the use cases or the use case model when he starts with the elicitation activity of the project. Prepared by an IT business analyst, use cases or use case model is utilized by almost all the stakeholders of an IT project, be them clients, software architect, project manager, software developers, testers, process owners, and it is the business analyst himself who will go through the use case model time to time. History of use cases. Use cases were pioneered or invented by Dr. Ivar Jacobson while he was working at Ericsson. Dr. Ivar Jacobson later joined the UML partners Booch and Rumbaugh in 1995. This led to the unification of modeling systems by the three IT stalwarts. Use cases also became an important part of the unified methodology or the unified modeling language. In the year 1996, OMG adopted UML as a standard for analysis and design of IT systems. Utility of a use case diagram or a use case model. You see, by now we are aware that almost all the stakeholders of an IT project refer to the use case model. Use case models are utilized both for new and existing systems. For a new software system or a new solution being developed, we capture the overall requirements of the project through the use case model. We are also able to identify in-scope and out-of-scope functionality through the use case model. This use case model is incorporated in various requirement documents. And friends, it is a must-use technique while we start analysis of an IT project. Use case models are also utilized for software solutions which are in existence. So for existing software solutions, we can explore the available functionality through the use case model. We can train others or train the newcomers of our team about our software through this model. We can also plan for new functionality or new features if we are aware of the current functionality and if we are aware of the requirements which we may expect from the system in times to come. In the last slide, we referred to the word that the use cases capture the overall requirements. So let us understand what are the overall requirements or top level requirements of an IT project. So I explain this with an example. Think of yourself as an IT business analyst who has been given task of doing requirements analysis for online railway ticket reservation system. For this online ticket reservation system, a client may tell you that this portal or this system will allow registered persons book tickets, cancel tickets, view availability of tickets on trains. However, it will not allow them to reschedule tickets. So these are, you see, overall requirements or a top level functionality of the project. With the use case model, you will be able to capture overall requirements or top level functionality of the project. And you will also be able to demonstrate out of scope functionality or document the out of scope functionality of the system. Decoding a use case diagram. Now it's time to decode a use case diagram or a use case model. Have a look. Here you see a sample use case model for an attendance software system. This is how a use case model will look like when you prepare the same. Use cases, notations and terms. You see, UML diagrams use standard notations and terms. Our world is easy, quick and precise when we use standard notations and standard terms. Use case notations. While we learned about the basics of UML in another video, we know UML diagrams or UML models have got standard notations and standard terms. The notations of use case diagram were to be seen in the earlier slide. So out here I have just segregated those notations, and these were the main notations, or these were the notations which were shown in the earlier use case diagram. The notation which I point here is that of an actor or a stickman. Another notation is that of use case. Third notation, which is a straight line, is the notation of association relationship between actor and a use case. And the rectangle is the notation for the system boundary or the system or subsystem for which the use case model is being prepared. Diving deep into use case diagram notations. Now it is time to have a deep dive into various notations which are present in a use case diagram or a use case model. Actor. The notation of actor is that of a stick man. Below this stick man, the actor role name and not the title of the actor is given. Actors are human or non-human entities which interact with the system or subsystem in question. So you see, actors can be other pieces of software or hardware which interact with our system. Interaction of actors with the system is captured by use cases. So you see, actors carry out certain goals with the system. Alternative notation of an actor. What you see here in form of a rectangle is the alternative notation of an actor. Though the popular notation of the actor is the stick man, this is an alternative notation. In this notation, the word actor is written inside the guillemot, and below this word actor, the customer role name is written. Having learned the notation of the actor, now it is time to learn how to identify actors in a system which we are doing modeling. So, to identify the actor in the system, you need to answer some of the following questions. Who uses this system? What other softwares interact with this system? Who does the installation, startup, shutdown, backup, maintenance, etc. for this system? From where does our software or our system receive data from, and from whom? Where does our software send data to? What inputs are received by this system? And all the human and non-human entities which will interact with our system or subsystem in question will be actors to this system. Instance of an actor. Let us learn about the concept of instance of an actor through an example. Think of an attendance machine where the employees have to mark their attendance. Think of a situation where several employees are standing in a queue and marking their attendance on a biometric machine. Each of these individuals who are standing in the queue is a different instance of the same role for the system, that is, let's say, an employee. So this is what we call as the instance of an actor. Primary and secondary actors. Now it is time to learn about primary and secondary actors. You see, primary actors in a system or a subsystem initiate use cases. Secondary actors do not initiate use cases. Use case. The notation of use case in a use case model is that of an ellipse. Use cases depict pattern of behavior of the system or subsystem. So you see, use cases are goals which an actor carries out through the system. A use case name is always a verb. So use case names are written in a particular method. So it will be something like this: mark attendance, withdraw cash, check flights, book ticket, etc. Use cases which are shown inside the system boundary or the rectangle are the in-scope functionality of the system. The use cases which are shown outside the system boundary are out of scope functionality. So you see, utilizing use cases or the use case model, we can differentiate between the in-scope and out-of-scope requirements. How to identify use cases in a system? As a modeler, you need to identify the use cases which are to be carried out within your system. So these are some tips or some pointers which you can take note of. What goals primary actors want to achieve with this system? How does software interact with other softwares? Why does software interact with secondary actors? What are the primary goals of this software? Instance of a use case. Let's learn about this concept of instance of a use case through the example of an ATM subsystem. Think of an ATM machine where numerous account holders are standing in a queue to withdraw cash. So, several account holders carry out the same use case, withdraw cash, through its different instances. Scenario of a use case. A use case in its different instance can take up a different scenario. By now, we know what do we mean by instance of a use case. So think of a situation where several account holders are standing in queue to withdraw cash from ATM machine. When we carry out this use case in its different instances, a different scenario can come up. So say for example, for the first person who is standing in the queue, let's say he is able to withdraw cash successfully. The second person in the queue is denied the withdrawal because he has got inadequate balance in his account. By the time the third actor or the third person is carrying out the same use case in its different instance, the ATM has run out of cash. So, there are different scenarios for the same use case in its different instances. Use case scenarios are not captured in the use case model. If you wish to capture the use case scenario, you need to prepare the UML activity model, or you need to prepare a documentation which can accompany your use case model about the scenarios which can happen while we carry out different instances of the same use case. How to capture use case scenarios? Use case scenarios are not captured in use case models. You can discuss them in the associated documentation of a use case model. Use case scenarios are captured in UML activities or activity diagrams. System boundary. The system or subsystem for which we are preparing the use case model is called the subject. Notation of system boundary is that of a rectangle. The actors are shown outside the system boundary. The in-scope use cases are shown inside the system boundary. Out-of-scope use cases are shown outside the system boundary. The actor and use case relationship is the association relationship between the use case and the actor, which is depicted by a straight line. Modeling in scope and out of scope use cases. As you can see out here in this diagram, there is one use case which is shown outside the system boundary, which is the stop check payment. For other use cases like withdraw cash, send SMS, check account balance, view reports, block card are shown inside the system boundary or within the rectangle. So for this ATM system or subsystem in question, the use case stop check payment, which is shown outside the rectangle, is out of scope use case. That is, this functionality will not be present in the software which will be built. All other use cases within the rectangle are in scope use cases. Use case diagram relationships. Now it is time to learn about 5 relationships which are there in a use case model. Relationships in a use case diagram. There are 5 relationships in a use case diagram. They are association relationship between actor and a use case, generalization relationship between actors, Generalization relationship between use cases. Include relationship between use cases. Extend relationship between use cases. We will learn about each of these relationships one by one. Association between actor and a use case. Association or association relationship between actor and a use case is shown by a straight line. One actor can be associated with one or more use cases. You can see here, in this system, the account holder can withdraw cash and he can check his account balance. A use case can also be associated with more than one actors. Generalization between actors. In a use case model, we have two kinds of actors, a specialized actor and a generalized actor. In the next slide, we will learn about the specialized actor and the generalized actor. Here, we will learn about the notation for the generalization relationship between actors. The notation for the generalization relationship between actors is that of an arrow with an arrowhead as shown in the picture. The arrow initiates from the specialized actor and points towards the generalized actor as is shown on the right side. Generalized and specialized actors. Generalized actors are associated with one or more use cases. Specialized actors are related with generalized actors through a generalization relationship. They are associated with all the use cases of a generalized actor and one or more additional use cases. Having learned about the notation of the generalization relationship between actors, which is that of an arrow, and having learned the definitions of the specialized actor and a generalized actor, now it is time to learn about the generalization relationship between actors through an example. Have a look at this attendance system. In this attendance system, the employee can carry out use cases which is mark attendance and apply leave. There is also an administrator who administers this attendance system. This administrator is also an employee of the company. So, this administrator, just like any other employee, can carry out or will mark his attendance and apply for leave. In addition to this, an administrator can block an employee, let's say when he resigns or when he is terminated from the employment, and he can also view certain reports. So, administrator is the specialized actor and the employee is the generalized actor, and the relationship between these two actors is shown by the arrow as is being seen in the slide. So the administrator of the attendance system can carry out all the use cases which an employee will carry out, and in addition the administrator can carry out two more use cases for this system, which is view reports and block the employee. At the cost of the repetition, administrator for this attendance system is the specialized actor and employee is the generalized actor. Use of the generalization relationship between actors brings both clarity and neatness to the use case model. Generalization between use cases. So this is yet another relationship in a use case model. At times, one use case can be carried out in more than one ways. Let us understand this with an example. Say, there is an administrator for a net banking solution. This administrator has got the privilege to deactivate an individual debit or credit card in light of some spurious activity, or while he goes through a report. So these are the two methods. So the first method is, let's say if I am the card holder, if I report my card theft, then the administrator can block my card right away. Or let's say while the administrator is doing some online monitoring and if he finds some suspicious activity for a given card, he can deactivate that individual credit, debit or cash card. There is yet another method. This administrator checks the weekly report of unusual card usage, which is generated, let's say, every Thursday morning. And based on his algorithm, he can block cards through a batch program. So the use case block card is being carried out in two different ways. Use case generalization relationship notation. So notation of the generalization relationship between use cases is that of an arrow. Arrow initiates from the specialized use case and points towards the more general use case name. So you can see here, deactivate card is the generalized use case, and then there are two specialized use cases, deactivate card one by one, and another use case is deactivate card through batch program every week. Abstract and real or concrete use cases. You can see here that for the use case deactivate card, we have used the alphabets in italics. This shows that deactivate card as a use case will never be carried out in its generalized form. Only the special use cases deactivate card one by one and deactivate card through batch program weekly will be carried out. Please note that this concept of abstract vis-a-vis real or concrete use cases is used by certain experts or authors of UML. This vocabulary is not part of a standard UML documentation from OMG. Include relationship between use cases. There can exist an include relationship between two use cases. The notation for the include relationship is a dashed arrow with the word includes written over it within a element. The arrow initiates from the including use case and it points towards the included use case. We will just explain what we mean by an including use case and what do we mean by an included use case. Have a look at this use case model. This use case model of an ATM subsystem explains the include relationship. Let's say you are an account holder. As an account holder, you go to the ATM machine to withdraw cash. Whenever you withdraw cash, an SMS is sent to you compulsorily. So, withdraw cash is the including use case and send SMS is the included use case, and the included use case is compulsorily carried out. Please focus on this word compulsory. So whenever we carry out the including use case, the included use case is compulsorily carried out. Extend relationship between use cases. Sometimes one use case may optionally extend its functionality to another use case. Here we must focus on the word optional. The use case which extends its functionality to another use case is called the extending use case. The use case whose functionality may get optionally extended is called as the extended use case. And the notation for the extend relationship is the dashed arrow, and over this arrow the word extends will be written within a element as is shown here. Friends, I am sure that the definition of extend relationship which we covered just now is not enough for you to comprehend the concept of extend relationship in its totality. Let us understand the extend relationship with the help of an example. Think of a estate selling and broking system. Here, the customer visits the estate selling and broking office. The objective of the customer visit is to get recommendations for himself to purchase an apartment if the recommendation suits his need. So the estate agent asks the mobile number of the customer and confirms whether the record of the customer is present in the database or not. If the record is not present, he quickly captures the record by putting into his database the mobile number, name and email ID of the customer. Now the estate agent searches his database of apartments to recommend available apartment purchase options, and he gives the criteria of search as shared by the customer. Now the search options come up, and he shares these search options with the customer who's sitting across the table. Optionally, the estate agent can reserve a specific apartment for the customer if the customer so desires. This is how we capture the scenario we discussed in a use case model. So there are 3 use cases: recommend apartment, search apartment and reserve apartment. So in the recommend apartment use case, we capture the basic detail of the customer. Then whenever recommend apartment use case is fired, search apartment use case is always compulsorily included. So there is an include relationship between recommend apartment and search apartment. Depending upon the search results, a customer may optionally ask the estate agent to reserve the apartment. So reserve apartment use case optionally extends its functionality to the recommend apartment, and the arrow initiates from the extending use case, that is the reserve apartment, and it points towards the extended use case, which is the recommend apartment. Before we move on to certain other topics, let's revise the notation for extend relationship between use cases. So the notation for extend relationship is a dashed arrow, as is shown here, with the word extends written inside the guillemot on the arrow. The arrow initiates from the extending use case and points towards the use case whose functionality gets extended. Additional topics which you cannot ignore. Friends, in this section, we will learn some additional important topics which are present in a use case model. Notation for comment. You can put your own comments in a use case diagram or a use case model. Notation for a comment is a flipped rectangle as is shown here. This comment is connected with the object whose explanation is being provided through a straight line. So the comment notation is explained here. Whenever an account holder withdraws cash, an automatic SMS is sent, which is shown through the include relationship. This can also be shown right onto the diagram through the comment notation as is seen here. Notation for conditions and utilizing object constraint language in a use case model. Notation for a condition is similar to that of a comment. However, in case of a condition, the notation is a flipped rectangle and any condition is written within the curly brackets as shown here in the diagram. Object constraint language can be utilized for writing down the condition. Documentation for a use case model. You see, now we have prepared our use case model. It is time to prepare associated documentation which will go alongside this model. Method 1 is that you can write in a paragraph sequence of activities which will happen in a use case diagram. Method 2 is the following. For every actor, prepare a table which will have 2 columns. Column on the left will have actor stimuli or the actor's interaction with the system, and column on the right will mention the system or software response. Method 3 is any other procedure or standard document template which is used in your organization. You can follow that. Now it is time to learn use case documentation through an example. Have a look at this model. If we are to produce associated documentation for this model, it will be something like this. So this is the first method, which is the use case documentation paragraph style. You can see for the model shown earlier, we have prepared a paragraph which conveys all what happens in the use case. So our developers and other stakeholders can go through this paragraph in addition to the use case model, and they can cross-check and cross-verify what is written here and what is shown in the use case model. Use case documentation tabular style. For the model which we discussed or which we saw earlier, this is how we can document the use case model in a tabular format. So we have identified an actor who is an account holder. We have in the left column mentioned the interactions of the account holder with the ATM subsystem. The rows in the left column provide the account holder activities, and then the corresponding rows in the right column provide the ATM subsystem response. Producing use cases. Friends, by now we are fully conversant with the use case model. Now it is time to learn a methodical procedure on how to produce a use case. To produce a use case model, dear friends, you need three things. First, you should be conversant about the UML use case model, which by now you are. Second, you should be conversant with the overall requirements of the system or subsystem for which you are doing modeling, which you can obtain by eliciting requirements from the stakeholders of your system. He can be a project champion, or he can be some key stakeholder at your client's organization who is aware of the overall goals of the system. The third requirement is that of a modeling tool. So you should have access to a modeling tool, and you should have a fair degree of proficiency in utilizing that modeling tool. Step-by-step method to produce use cases or to prepare a use case model. Friends, you can follow these steps to prepare your use case model. Identify actors, identify use cases, identify relationships in the use case model, start your modeling activity, start your documentation, share the use case model with your peers, discuss the use case model with them, revise if required, and then share again. And when this use case model gets approved, you can publish it. Popular use case modeling softwares. So friends, these are some popular use case modeling softwares. Visio Professional 2016, which is the current version of Visio. So Visio has got two versions, Visio Professional and Visio Standard. So the UML modeling templates are available only in the Visio Professional version. IBM Rational Software, Enterprise Architect, and then there are many more modeling softwares through which you can prepare your UML models. Summary. Friends, we have covered a lot in this packed session. In fact, if you ask me, I rate use case modeling as one of the top techniques utilized by IT business analysts. And I must tell you that what we have covered in this session so far will make you a proficient use case modeler. So you can start your project or start your requirements elicitation activity or start your requirements process by preparing the use case model. The use case model will allow you to capture overall requirements, and to prepare a use case model, you have to identify actors, you have to identify use cases, you have to identify relationships within the use case model. The use case model will also allow you to capture in-scope and out-of-scope use cases. Please remember that UML is all about its terms and notations, so you have to be particular and exact about the notations and style. Once you prepare your use case model, you and your stakeholders are now ready with the detailed overview of the system. Friends, thank you for attending this session. This is your trainer Vijay Shukla, who's on your side to make you a proficient IT business analyst